Hello, everyone. My name is Tim Chou, and I'm here to talk about 5 key technologies that I think could make a difference in your business, in an industry, and frankly, in the development of a country. One of the technologies that I think many of you have heard about, because every cell phone provider out there, every cell service provider is talking about it, is 5G. And so what I want to do in the next 15 minutes is give you an understanding of what 5G is, what it can do, and what some of the potentials are for that technology. This is actually a presentation I developed for the 6th largest law firm in the world to try to help them understand what 5G is and frankly, what 5G isn't. Let me start by taking you a little bit back in time. In the world of phones, once upon a time, right, we used to have phones that had cords on it. For all the young people, they're probably wondering what that looked like. Around 1994, radios got put into handsets, and so the cord disappeared. Obviously, the connection to that phone in 1994 was still a landline. But by 1997, we started to see, right, what are, in essence, modern day cell phones, which are, completely cordless. Just to go back in time a little bit, before 1997, it's odd to think about this, the computers were corded as well. And there was, you checked into a hotel, you looked around for the Ethernet cable and tried to plug it into your laptop. But again, starting in about 1997, Wi-Fi entered into the picture and cords. In fact, there's no laptop today that even has an Ethernet connector on it anymore, other than through an adapter. So cordless Wi-Fi based computing, right, took over basically at the beginning of this century. And then the other big thing that happened, which you're all aware of, is the merger between computers and phones happened with the advent of the iPhone, which is in essence a computer that has every bit as capable as the laptop that you have. And along with that came advances in cellular technology, what was referred to early on as 3G, what is prevalent around the world, which is 4G, came out in 2008. These all have these G's, so to speak, all have to do with what frequencies are being supported in terms of how you communicate. So we just talked about Wi-Fi a little bit, and you see right here that Wi-Fi occupies this band around 2.4 gigahertz. And now you can see where 3G, 2G, 3G, 4G, the different bands that are occupied here. Now these bands can vary some country by country, and they generally are administered in the United States by the Federal Communication Commission, in Brazil, I'm sure, by a federal agency, which licenses this spectrum to be used by providers. There is clearly unlicensed spectrum, which is what Wi-Fi is. There's nobody who regulates that. And so any of us are free to use that part of the band. So what you're seeing here is both an example of what frequencies are adopted that are regulated, and obviously one which is unregulated. A little short course in radios and electrical engineering, just so for you to think about this. So there are trade-offs between the frequency that the radio transmission is occurring at and the range and the data rate. So let's just start here with, at the high end of this, right? If I'm operating at 50 gigahertz, I can get large data rates being supported by high frequencies, which is why, as you will see in a minute, you'll see some of the 5G spectrum is at high gigahertz frequencies. But the disadvantage of this is that the range, how far it goes with a given amount of power, is much less. So you're seeing here at 100 meters versus when you go to much lower frequencies, so 500 megahertz. Yes, I get lower data rates supported, but I can get farther and farther distances. There are actually some Department of Defense applications that operate at very low frequencies to be able to reach submarines, et cetera, at very long ranges. So there is always this trade-off. The implication of this trade-off, by the way, in the world of 5G, as you get to higher data rates, is you've got to have more antennas. And it is, I think, I'm unsure in Brazil, but I know in the United States, somewhat of a controversial issue because a lot of people don't want to have a antenna in the back of their yard. But in order to get high-speed 5G level coverages, we are going to have more and more antennas out there. The other thing for you to think about is the actual architecture, and this has changed in the world of 5G, of how you route a call from person to person or person to thing is being changed. And it is a much more software-defined architecture than was done before, which enables it to operate much more efficiently. But that network architecture is also changing as part of the work in developing 5G technologies. I made mention earlier that we talk a little bit about spectrum. So here you're now starting to see what the 5G frequencies look like. And again, I'm pointing out that what you're seeing here is much higher frequencies, that up there, 39 gigahertz, right, et cetera. What you're also seeing on this chart is at least a year ago, August 2019, who was operating in which portions of the spectrum. You see, at 28 gigahertz at Verizon and T-Mobile and a Uruguayan cellular provider. Almost everybody, as it says here, is deploying in these 3.4 to 3.8 gigahertz. Again, this is all regulated spectrum. But also, just to note it, 5G has also been deployed at the lower end, meaning the 5G standards. That 700 megahertz down there, Sunrise, T-Mobile, is what some people will tell you is NB IoT, narrowband IoT, which is designed to try to connect lower bandwidth things like, power meters in a home, et cetera. With lower, you don't have as much data, but you have way more of these devices, and you want to scatter them across larger and larger distances. So there is a portion of the 5G specification, the deployment, which is down here at the lower end. We'll talk a little bit about this in a section that is, or in the lecture about the Internet of Things. So this is giving you a sense of the spectrums and therefore obviously the speeds that are possible in the world of 5G technologies. This is showing you a little bit about what bands are being used country by country. I was reviewing this yesterday and realized for whatever reason, this one does not have Brazil on it. Just to point out for the fun of it, I spent some time with the guys at Swisscom, and in 2019, they were actually predicting 90% coverage for the country at the 3.5 gigahertz band. I haven't checked in with them as to where they are right now, but this gives you a sense, and you're seeing lots of 3 gigahertz frequencies up there where 5G is in a lot of countries around the world. Here is, if you're not following this, I mean, China's been a big, has pushed this technology a lot, both by the development of a lot of the radio technology, Huawei, et cetera. And obviously, it's a cell phone first country. And so there's massive deployment of 5G technology throughout China. So what are the benefits of this 5G thing? Well, yep, it's faster, right? So we talked a little bit about that. So I don't know how many of you watched the movie Guardians of the Galaxy, but you're seeing here that, oh yeah, on a 4G network, it would take 6 minutes to download the movie, and on a 5G network, it'd be 3.6 seconds. So it is faster. The other thing is it is a lower latency. So some of you may not know what the word latency means. Latency is the amount of time it takes, and what you're seeing here, to transmit some data from my cell phone on the left to the cell phone on the right. How much time does that take between the time I send it to the time I receive it? just to give you a sense of what latency might mean with things that you commonly think about. So down here at a human, 1.6 seconds is basically the fastest amount of time that humans will react to something. So, in an example of the ball comes rolling out in the street, how quickly from the time you see the ball rolling out the street to you hit the brake pedal, 1.6 seconds is kind of fast for a human. That's human latency. LiDAR is a technology, a light technology. It's being used in a lot of autonomous driving. That gives you a sense of that. There's 4G, 50 milliseconds. 5G is spec'd at 10 milliseconds, right? And then just to give you a sense of how fast can be. So if you're interested in high-speed automated stock trading, where you want really fast latencies, meaning from the time I see the data till the time I make the trade is really fast, that's showing you how fast is, right? That's 0.002 milliseconds. And that's why, if you've ever looked at this, high-speed trading occurs in buildings that are extremely near the stock exchange computers. So that's how fast latency means in the world of trading. So 5G is, from a latency point of view, much faster than what we're seeing in 4G. And the final attribute of this technology is it allows greater density. So 5G is spec'd to allow for 1 million connections per square kilometer. So 1 million connections per square kilometer. So I had read this and went, well, I wonder what does 1 million mean, 1 million connections? So I thought, I'm kind of curious. What is the most densely populated city in the world? How many people are there per square kilometer? And it turns out, if you're wondering, it turns out it's Bangalore. Is actually a scene from that city. So you want to guess how many people there are? What's the most dense populated part of the world, which maybe Sao Paulo could be on that list as well. Well, it turns out that in Mumbai, it's 30,000 people per square kilometer. That's the most densely populated area of the world. So now you think about that. Okay, 30,000 people in a square kilometer, that's really dense population. Okay, every one of them have a phone. Okay, yeah, probably already true. Well, that's just 30,000 connections. So remember, I made the point that it's 1 million connections 5G is spec'd to. So what are we going to do with those 970,000 connections? And I think that's where, and we will talk about this in a subsequent talk, I think it's really going to be about how do we end up connecting a lot more things, whether that's an ultrasound, tractors, MRI scanners, automobiles, compressors, et cetera. The opportunity to connect these things is really, I believe, what's going to end up happening with 5G technologies. For all of us as consumers, do we really care if we download the movie 5 times faster? Latency may turn out to be an interesting attribute, particularly when you talk about autonomous cars, et cetera. But I think relative to density, it's not going to be because we have a lot more people. It's going to have a lot more things connected. So with that, hopefully you got a brief but important kind of understanding of what 5G technology is. Faster, better latencies, higher density connections, and what this technology might mean for us in the future. Thank you.